Hello everybody, it's Crazy Logics 007 on YouTube, Crazy Logics in the forum, and everybody else just calls me Damon. We got a Apocalypse. I think this is a 4900.1D. We'll see here. This is Jermaine's. You got to see about it. He's a local competitor who has had a couple amps go down on him. Somewhere I have. There it is. Exacto knife here. Get this thing open. Let's do the initial troubleshooting. I'm not going to make this a boring talk a lot video. I talk a lot anyway. Everybody probably just let me highlight it, I'd say. But I thought I'd do one of these. I do a lot of these SFBs and AABs, you know, whether it's Sundown or Deaf Bonce, it don't matter. So it is this is the 4900. Not sure. It'll be around the 5,000 watt for if it's a SFB, if it was a like a Sundown. They're the same design. You'll notice this design is kind of going away. And that's because it's not a very robust design. When it comes to competition, anyway. Competition guys seem to be able to blow them up pretty easy. So, yes, they put out a ton of power, but kind of got to be gentle on them. So, they're fantastic for, you know, size and everything. Makes it really, really nice. You can get a lot of power in a small size. Of course, that means heat sink's not very big. And let's see if I can zoom in just a little more. Whoa. Let's see my just absolutely trashed workbench right now. Right about there, maybe. Anyway, so I can get some stuff in there. So pretty simple. You know, you got your input. This has got dual power supplies, so we're probably going to have 4 FETs on each one. These should be the rectifiers. Let me double check that with my glasses here. No. We actually have 3 FETs on each one of these, and these are the rectifiers. So the power supply has 3 FETs, 3 FETs, 3 FETs, 3 FETs for each one of these. The input caps. We got a swollen cap right here. Right off the bat, I can see that. I don't know if I can. That sucker's all bulged up. Super common in this design for the input caps to swell and stuff. They are just super cheap. You know, it's built to a price point. And then we have 4 FETs, so you would have high or low. I don't know which it is on this. I don't care. You know, but you're going to have 2 banks, and it's got 2 chips driving it. That's C5, which is going to be the, I'll tell you the part number in a little bit. You can watch some of Bear Vid's videos. He goes over how to repair these pretty good. It is to note that if you have anything ever die on the outputs, always change out the Zener diode and the regular 41 what's the number? 4148 diode that's in there, and then check the gate resistor. So get up in here, goes out. So like for each one of these, there's a gate resistor here, and there's a little bitty 4148, and then there's this little bit bigger Zener. I'll tell you what Zener voltage that is in a minute. Pardon me, it's getting into fall now, and misery loves company, and so my wife gave me her cold and I'm feeling good right now, so I thought I'd come out here and at least troubleshoot this. If it's a cheap fix, we'll cheap fix it. You know, we already got a swollen cap. I've got some replacements for that. We're gonna look here. We got 12 volts here, ground there. So that's how we're gonna put our meter on. And we're just gonna put it to diode mode and see if it charges all the way up. If so, that means that there's no shorts on the power supply side. Now, this cap could potentially make us not make it all the way up there if its ESR has gotten too much, which is its equivalent series resistance. So we will see what this does. There may be a few times I gotta stop the video, and so there might be some breaks where I got to blow my nose. So pardon it, pardon the inconvenience. Looks like we're going to charge up good here, so that cap probably wasn't pulling us down. That's a good thing. We should make it to a 1 here. Yep. All right. So we know that's good. So shouldn't have any bad FETs. Spin them around. If you get a beep on a FET, it can be charging the cap. So I'm just going to go through. I do my tests of FETs in the diode mode. If you will go watch Todd over at Ellensburg Amplifier Repair and Service, he does his in ohm mode, and he's kind of got a reasoning for it. He's got a really great video. It's a little bit older. It's like 3 or 4 months old now, maybe. Really explains a bunch of his testing procedure. If I was a nice guy, I would look it up and show you by the end of this video. I'll try a screenshot of that video if you really want to learn some good stuff. But I'm a diode check kind of guy. He's a resistance kind of guy. You know, go over and tell him how wrong he is. That diode guys are better. Send him lots of love. He knows I'm joking. So on the rectifiers, the outer 2 legs should be a dead short, and then you should get a diode reading, or so there's a. It should charge up the caps to a 1, so that's what we're getting. And if you switch your probes around, you should get a diode reading, and that's what we get. We're just looking for shorts on the rectifiers. And I get over here. Sorry for my big bald head being in there. That's the outer 2, so that's fine. We just don't want shorts on the middle. That's good. And I always like to check that the outer 2s do make a beep. So we're going to look at the outputs. So far, so good. Oh, nothing there. Nothing there. Nothing there. So let's see what this thing does. I'll hook up some power here and see what happens. Blow my nose too. Okay, so we got the remote wire hooked up that I can pulse with my foot switch. I've got power and ground. I've got power up on the power supply, which I need to bump up a little there. And then I got a speaker hooked up also. These style amps, the SFBs and the AABs and stuff like that, gotta have a speaker hooked up to them. The output filtering circuit is built to such a low price point that it requires the subwoofer to be there to help act as part of the filtering. The subwoofer coil does. Otherwise, some of these will get, the components will get hot, and there is instances of it blowing the output section because it gets so hot that it runs something that makes a dead short. So I've got my low power supply going. So what we should see on the lights here, I'm going to turn off my overhead light. So you should be able to see these lights light up. Let's see if, yeah, there you go. All of them are going to light up. And we are getting a protect and clip. And it's going to try it again. You can see these lights. If I can zoom in a little, I'll do a zoom in. See if I can't get those lights. There you go, right here in this corner, right here. And the blue goes on. You should not have that red flashing. That means it's going into protect for some reason. And we don't have anything dead shorted. So what we're going to have to do is kill the power, turn our overhead light back on. Take my power away so I don't have to worry about that. That may have tried to charge up the caps a little, but we're probably going to have a diode or a voltage regulator in here that has went south. So I'm going to go through. I'm not going to bore you with testing every single one, but I'm going to go through and start hitting all the diodes and checking them both directions. A diode, when we read it, I'll show you here once. So if I'm checking this diode, and here is the little line. So let's do a little artwork. I gotta find room on my. If I can do it like this. So a surface mount diode is going to look like this. It's going to have its little tabs, right? And one end is going to either have multiple lines or one line or whatever. So that's just like this. This is the symbol for a diode. That's going to be it. That right there is the cathode. Okay, so when you put your probes, if you have them hooked up correctly in your meter, in diode mode, your probes actually act as this is the positive and this is the negative. So if I put the positive to the cathode and the negative here, I should get a reading like this of 0. When I switch it around and put the negative where the cathode is, where the line is on the diode, I should get a diode voltage drop somewhere between 0.5 and 0.7 on here. So let's just do that. I'm just going to pick one. I'm going to go with no drop there, and then we should see a drop across it. We should see a drop across it. We're not seeing a drop across that one. May have found one that was bad right off the get-go. Okay, let's try a different one because I want to show you this on the meter. So this one should have no drop, and this should have a drop, and we're not getting nothing. There we go. There's its drop. Let's test this other one up on these points a little better. Yeah, okay, what it is the solder down here has got a little oxidation to it. So, all right, so those two checked good. Let's see if I can do that one more time. So these diodes both have their line right there and right there. And so when I say you check with this here to here, I should be getting a voltage drop. I'm getting 331. 331. That's probably two of them in parallel maybe there. But that's what you're doing. You check it back the other way, and you should be getting nothing. You should be getting a 1, no conduction. Now, I want to show you this on the meter a little here. When I go in the direction where it's nothing, sometimes it'll charge a cap up a little bit. Let me do it the other way to make sure that caps. So there was the diode drop. This is the exact same measurement we were just zoomed in on. And if I do this, see how it flashed there for a second? Charged a tiny little cap on here, so it actually pulled a little bit of current, made this show a reading. So that's all I'm going to do is every diode in this output section. In the output section are these two chips. You may not be, yeah, right there. See how they're labeled C5 and C5? That is the output section. We're going to look all through there, and I'm going to test all those diodes, and then I'm going to test the diodes by these inductors. There's two inductors here, and that makes a little power supply, and these are little switching boost power supplies, and they take in like 5 volts and put out somewhere between 12 to 15 volts to provide the higher voltages needed, and the higher voltages needed for the op-amp circuitry in the input stage, so they're in the preamp stage. So that'll be something we do after we've tested all of the diodes. If we don't find anything bad, we're going to go and we're going to fire up some power to it, and we'll take some voltage readings and see if we got our voltages, because it's not uncommon for some of the voltage regulators, which are these little 5-pin chips. Right there in the exact middle, putting the glare on and off of it. But you can see that little 5-pin chip that was missing the leg in the middle. There's one over there. There's one over there. Like I said, those are little boost regulators. Also, I see something right now. Just looking sometimes helps you. See if we can get this zoomed in. This little resistor right here, it looks discolored, and its solder looks discolored. So zoom out. Will it give us a better... I don't know if you can see that, but it is slightly discolored. That's why I got eye loops besides my glasses. I'm going to give this thing a, once over, and we'll see what we got over there. See what that maybe is doing. Maybe we got an issue, because this chip right here that's right next to that resistor, that's the power supply driver. So maybe between some of that, maybe we had some dirty power, or he got it too low and it did something. I don't know. But I'm going to go through, do all that real quick. Tell you what I find. Okay, so that resistor, you can barely just see it, but it's supposed to be a 100, and that's on the SMD resistor. So let's do this. On an SMD resistor, you'll have like 100, or you could have 103. So what that means is it's a 1, a 0, 1, a 0, same here, but this third digit means how many extra zeros you add, because that's the multiplier. And the multiplier list is like this. It starts at 0, which means 1, 1, which means 10, 2 means 100, 3 means 1,000, and so that's what your multiplier. So this would be a 10 with no multiplier. It's only a 1, so it's 10 ohm. A 103 would be a 10 with 3 extra zeros, so it would be a 10K resistor. So this is supposed to be a 10 ohm resistor. So I've got my meter set to ohms. And right now it's reading about 45.2 ohms. So first thing we got to replace is that. Did it damage anything else? I don't know, but we'll have to see what that's feeding. See that smoke? Tried to power it up. It looks like we got a driver problem. Maybe. See if we do a little measuring. That's charging the cap. So that's the ground side. This should be positive side. Yep. We got that. So if we go from there to there. Let's say we need to replace that driver chip. Maybe. Something's causing it bad days. I always add leaded solder. Focus. MIC 4427 for that chip. You have to give me a second. The puppy dog needs let out for a potty break. Back to ohms and double check our resistor. And we've already fried that resistor. It's well over 100 ohms, so I change that out too. Again. Most of the time you can get them to slide right off. Heating both sides a little bit. Here and we check. We got a nice 10.2. And my wires are about 2, so or about 0.2, so Let's look at this one more time. See what happens. No smoke. That's good. Oh, let's get zoomed in a little more so you can see it. No smoke. All right, now we're going to zoom in on the lights because I want to show you what this does. And I'll turn the overhead light off. All right, so you should see the 3 lights over here. Oh, you can't see them hardly. See how our protect light went off, but our blue power light's flashing and our yellow staying on? These have a protect that won't let them come on unless there's sufficient current. So I'm going to add, now that we're not smoking stuff, I'm going to add in a little more juice. Look there. Came on. Zammy. So looks like it fixed it. We still need to replace this cap. I'm going to turn off the power. Ooh, pardon my cold. Now, big important thing. It just made power. It just filled these rails caps up with probably over 100 volts. So I'm just going to unplug the power. We're going to let it sit here for a while, and then when I go to dismount all this, we'll look. Should be able to see rail voltage. Probably here to here. Oh, maybe there. Be this way. There we go. Hang on. Let me spin around. 106 volts. So we're going to let this calm down. If I have to, I'll get a discharge resistor to slowly discharge that through the points before we take all this apart and swap out that cap. That is 4700, 25 volt. I believe these are the ones I've been using. These are NCs. They're not super high end, but these aren't super high end amps. These are a little taller than what's in the amp, but obviously we can go as tall as there. So that's going to work just fine. The spacing is the same. So I'll replace that one because it is bulged and is doing bad. Could you replace all of them while you're in? Yeah, if you want to. You know, from a bulge cap and a blown power supply driver, maybe somebody hooked up the positive and negative backwards for a second and got a big spark and probably killed that chip, burnt that resistor. It's my guess. Kind of seems like it might be. Probably puffed that one up. The fact that these didn't puff means they survived for a second. They are 25 volt caps, so they're a little more robust, when you're only hooking them up. But we'll see. Like I said, I got to let it all drain down. We'll replace that cap, then we'll test it. All right. If you look, I can measure here. We're down to 3.8 volts, which is fine. Start taking that out. To take these apart, you take all the clamps out. There's a ton of screws. On the bigger models, there's screws that are underneath, and actually this one's got it. Screws that are underneath the fan. So take the fan off. I don't take these end plates off the board. I leave them. I take the screws out. There's 6 of them on the end. That way, whenever I get all the screws out, I'll have to take this fan out. I won't have to take that one out. I'll have to release that fan to get to that other screw, and I can lift it all up. And these act as kind of the end supports to keep everything from getting all tore up. I'll show you when it's all out. All right, as you can see, we got it out. I had to take that fan free to get actually 2 screws out from there. We got this one to take out. Let's see if we can get there. We're going to add a little solder to make sure we get all the solder sucked out of here, because that leaded solder, big ground plane. My wife, the plague bearer, just came out in the garage, if you didn't hear. Oh, she didn't want nobody to know. She's telling me, shh. See if we can get that sucker to come out. Yep. It swole at the bottom just a little. Thankfully, on inspection, it does not look like it leaked any electrolytic out, so that is fantastic. I'm going to get my plastic stick, if I can find it. There it is. Plastic spudger. Push back some of the glue down mastic to make sure that the new capacitor fits in there flush. Flips all back. Sometimes you can get a hold of it. There we go. Peel a little bit of it out. This marked side over here is the negative. We take a capacitor, electrolytic capacitors, they're marked on the negative here. We'll slide it in. Get it in place. Got just a little so it'll hold. A little solder. On there. Oh, we're not getting enough heat. As soon as I get a little bit of solder daub down there, I'm going to go back under with my finger, pushing up against it and remelt it. Make sure it's flush. That looks good and flush. Good and attached. Shazammy, she done. Use a little E6000 to smear it back in, and I'll put it back in the heatsink and see you in a second. Okay, I got a little schmoo on that cap, gluing it to this one and down to the board. You notice I used a little power drill when I was taking it apart, if I've showed any of that. I do not use a power drill to put any of these back together. So here's the tip. You find a center screw, and you start there. And you work your way that way, and then you work your way that way. And that way you're making sure that the board is clamped down flat. You start at the ends or something. You can start at one end and go all the way. I like starting at the middle because it divides it in half, kind of makes it squish to each direction. It's also the same with putting your clamps in. I always start my clamps after I've got screws in that are holding the board flat. I get my screws and I work my way out so that everything stays compressed in a nice orderly fashion, and it should be shouldn't get any bind or any kind of thing like that. If you're a gearhead kind of guy, it's like tightening lug nuts and head bolts and things like that. You got a pattern that helps spread out the force and properly make sure things are flat and stuff. So out of habit, that's how I do it. I recommend you do it too, just because it's a good habit to make. It'll help you with anything that you're fixing. And like I said, when putting them back in, no power tools so you don't strip it. As soon as I get these 4 screws in this corner in, I can put the fan back in. We'll get all the clamps back down, and then we'll musically test it. I'll finish this up and we'll see. All right, we're ready to power it up and give it a test here. I got some, pardon my big fat head, I got some test music. I don't know if you can hear that. There we go. Bam, she's fixed. So, bad chip, burnt up resistor, bad cap. You know, probably reversed the voltage there. So, don't do that. That's bad. I'll do a little load testing, and this thing should be good. We'll go to the next one after this. So, anyway, like I said, these amps are built to a price point. Fantastic, small size, gives you a lot of boom if you're careful with them. You know, my opinion is shouldn't probably be used in competition, because it seems like the competition guys are tearing them up pretty good, but pretty fantastic if you want some boom in your car for a cheap price point and a good chunk of power so that you can enjoy it. But you know, be responsible, practice safe sound, watch out for the rail voltage, like, comment, and subscribe. Appreciate you guys. I'll do a few more of these. I think we got some multi-channel ones and stuff that we can look at. I'll see what I got. And until next time, thanks for watching.